Lesson 2.5 is solving equations with variables on both sides. So you have solved two-step equations, you've solved multi-step equations, and now you're going to solve equations with variables on both sides. The equation that's true for all values of a variable is called an identity. So if it's true for every single value, then it's called the identity. And here we're going to go ahead and solve the equation with variables on both sides. The first thing you want to do, if it's necessary, is you simplify each expression. Remember, the expressions have one or more terms separated with addition or subtraction. And here we don't have any simplifying to do. So step one, there's nothing to do as far as excuse me, simplifying the expressions. So then you go on and you just make a decision. Do you want to move the variable term to its left or to the right? It doesn't matter, there's no right or wrong answer here, but I want you to write down to move a term you add or subtract. To move the entire term. So I'm going to go ahead and I'm going to bring the 3x to the left, so I'm going to subtract it, and you can only subtract like terms. So I have 13 minus 9x equals negative 14. Well, this is just turned into a two-step equation. So now I will subtract the 13 from both sides. I end up with negative 9x equals negative 27. Divide by negative 9. And x equals 3. I would have had the same answer if I had added 6 to both sides. So it doesn't matter what direction you take your variable term. Next, we're going to solve an equation with grouping symbols. In other words, we're going to solve equations that have parentheses. So this is what I was talking about. We need to go ahead and simplify this expression. Now I am going to go ahead and distribute the 1/3, and the reason I'm going to do that is because both terms are divisible by 3, so it's pretty easy to simplify it that way. So a third of 9x is 3x. It's the same as saying 9x divided by 3. And a third of negative 15 is negative 5. Again, I just make the decision, do I want to bring the variable term to the left or to the right? I generally bring to the left, it doesn't matter though. When I do this, 4x minus 3x is just x, so I have x minus 7 equals negative 5. This actually turned into just a one-step equation where I add the 7 because my coefficient here is really a 1. So I end up with x equals positive 2. If you are going to try to multiply this by a third, I just want you to use caution because I know we did those problems yesterday. Or multiply this by 3, I'm sorry. You could still do that, and I will do that on the other side just to show you. But what you have to do then, so if I multiply this by the reciprocal, I have to multiply this entire expression. You cannot just multiply the 4x. So if I do that over here, that would give me 12x minus 21 equals 9x minus 15. I can do the exact same thing. I'm going to subtract the 9x from both sides. That gives me 3x minus 21 equals negative 15. I would add the 21. 3x then equals 6. Divide by 3, and x will still give me 2. The only reason I showed this to you is because I want you to use caution. Again, if you multiply by 3, the reciprocal, you have to multiply the entire expression on the other side by 3 as well. Let's keep going. So these problems say solve the equation if possible. So we have on both sides here, we have the distributive property, so I'm going to go ahead and use it. 4 times 3x is 12x. 4 times negative 2 is negative 8. 2 times 6 is 12x. 2 times 1 is 2. I'll subtract the 12x from both sides. And I end up with negative 8 equals positive 2. That's not a true statement, and my variable terms have dropped all out. So if your results end up being not true, if the variables drop out and it's not true, you simply say no solution. So there's no solution to this one. Let's go ahead and do this next one. 4 times 4x is 16x. 4 times negative 5 is negative 20. 2 times 8x is 16x. 2 times negative 10 is negative 20. Again, I'll subtract the variable term, in this case, the 16x. I get negative 20 equals negative 20. So again, the variable terms dropped out, but now I do have a true statement that's left, and we call this the identity. That was the first definition that we went over. Let's try one more. So I'm going to go ahead again and distribute the 1/5 because I know that 15 and 5 are both divisible by 5. So 1/5 of 15n is 3n. 1/5 of 5 is 1. I'm going to go ahead this time and I'm just going to be different. I'll subtract the 3n from both sides just to show you it doesn't matter. So 1 equals 5n minus 9. I'll add the 9 then. So 10 equals 5n. I'll go ahead and divide by the 5. And n equals 2. So no solution for the first one, the identity for the second one, and the third one can be solved. Okay, I've put 2 up here, 8 and 9, and I want you to work on these on your own. So on your own, and I want you to bring these examples back tomorrow and we will discuss them. I'll have you go over them with your AB partner and then we will discuss them as a class. So that's it as far as notes are concerned. I will go ahead and give you the assignment if you'd like to get started on it. This is lesson 2.5. And it's page 107 to 110. Problems 1 and 2. 8 to 46 even. 49, 50. 52 and 54. All right. I will talk to you.